All right, so this is section 3.3, graphics in the media. We're just going to talk about some of the graphics that you might see. First of all, you might see some multiple bar graphs and line charts. And this one is showing two sets of bars, one for men and one for women. So you're going to have a like a key or a legend to kind of explain what's going on. So you might end up with multiple things. This is not something we'll necessarily draw in our class, but it's something to be aware of. Make sure you're paying attention to what's kind of going on with those. This one is a time series data, but it's got 4 different lines of data going on. That's not a high school graduate, some college or associate degree, and a bachelor's degree or higher. So, and it's talking about the unemployment rate and how it's higher with if you don't have high school degree, and it's lower if you have a bachelor's degree. All right, next set of data. This is a stack plot, which shows different data sets in a vertical stack. So these are the percentage of total spending, and this is the year. So you've got your national defense, Medicare, Social Security, interest debt, and all the other spending that happens. So this might be another type that you see. And then we've got geographical data. This is data that it can vary continuously across geographical areas. You might see it as a contour map is more convenient. This figure shows one common way of depicting geographical data. So this one actually shows per person the energy usage by the state in units of gallons of oil and equivalent. So, and the oranges are the smaller amount going to yellow and then the cream and then purple, green, and blue. So that means the blue state uses the most energy in oil. And then the green states, and then it would be the purple states going down to the beige ones, and then the yellows and the orange ones use less amount of oil. So our next graph is this is a contour map of the temperature over the United States at a particular time. So it looks like this was probably not quite freezing winter, but it's got the cooler temperatures up here. But I notice in the bottom temperatures, we're only running about 70 degrees, a little over 70 down here. And it's going from like 20s to 30s. Your 40s are in your beige, and then 50s are yellow, 60s here, and then the 70s and above. So that just kind of shows you how the temperatures go. It would not always look like this. Sometimes it might be plunging down this way. This just happens to be on a particular day when they did it. All right, we can also have three-dimensional graphs. So instead of just a bar graph, it's actually got a 3D effect on it. So this is our essay grades, and they just dressed it up and made it look a little fancy. Now this one is a three-dimensional. This is 3D on those. This is now a three-dimensional on carbon dioxide emissions. So these can be a little bit harder to read because it's hard to tell, like, where is it hitting. So not necessarily one of my favorites. All right, so we have one question in here. Does it make sense? I used a contour map to show the ages of full-time students at my college. So a contour map probably is not the best choice. That would be hard. A contour map is usually like we did for the temperatures, where it's over a place of it. But your age groups aren't going to be like the temperature groups up here. You can't just necessarily do your age groups that way because that's like over a map, right? This is not geographical data. So I would not use a contour map. You need to use geographical data if you're going to use a contour. There's other ways that we could do that. We could do like a bar graph. We could do a histogram if we wanted to bend the data, that kind of stuff. Okay, so would not use a contour map. All right, so that's some of the maps. This one's pretty short, so I'm actually going to combine our next set of material in here. And this is a few cautions about graphics. So the first one is perceptual distortions. Many graphics are drawn in a way that distorts our perception of them. So the figures are going to show that there's one or more common types of distortion. So in this case here, we have the dollar-shaped bars are used to show the declining value of the dollar over the time. The problem is that it's got like an area on it. It's not just like a line. And so it makes it look even bigger than it is. Okay, so not just the length, but the size on the side get smaller as well. So it's more of a area that's shrunk instead of the length of it. Another thing you have to watch on, this is the same data, and this is the percentage of college students since 1910 who were women. If we look at this one, we can see it starts at 0 in 1910, and we can see the kind of the dip right here and going forward, right? This is the same part, but they've changed the scale. This is counting up by tens. This now does not start at 0. It starts at 30, and it counts by tens, but the spacing is way bigger, right? And you don't have anything past 60, so you don't have the same amount of scale on there. The years are still the same, but because they've changed the scaling, it makes it look way bigger versus over here. Here we can kind of see the trend. It declined a little bit and went back up, and it's gone higher, but this makes it look like such a bigger thing. So be careful of that. Now, this one here, the first graph shows the speeds of the fastest computers have increased with time. So we're going from like about 1965, and this again is about to 2015. But the second graph has a scale that is called an exponential or a logarithmic scale. During COVID, we saw when you could go in and see like the number of cases, you could change the graph and you could see the exponential scale. Now, so this one here, if we're looking, it's got the same years, right? But up here, this is millions of calculations per second, and this is trillions of calculations per second. So they've changed the scaling, and this one's like based in tens, right? And but this one here, well, because it starts like 0, 10, 100, 0, so it's in kind of like that. But when they changed it to an exponential one, holy snikes, that jumps. So it looks like all of a sudden it didn't. So this one kind of shows like what we would expect, that computers got faster and faster and faster and faster, right? But this makes it look like they didn't gain any speed at all, and then all of a sudden they went crazy. So just be aware of what you're looking at in comparison, okay? The next graph is, this is about the percentage change in college. So we've got the same information again, and we're looking to see if college is getting more or less expensive. So we've got the public 4-year is in maroon, and the private 4-year is happening in the blue. So when we look at this scale here, it looks completely different than when we look here. So if we look over here, we see that the costs are increasing. Now, private is, or the public is not increasing as much as private did. We've got a little bit more slope going on there. But, and we could see that even if we took like a ruler, we can see that the angle of the increase there is not the same as the increase here, because this one is down like this. So if I come up here, we can see it's not the same angle. So the the angle is increasing. And we can, this one's got cost over here. So this is saying, hey, the cost is increasing and it's going up to here. This one over here is the percentage change from previous academic year. So this is showing you how much it's changed from one year to the next. And so this makes it look like the costs are going down. But actually, it's the percentage change from one year to the next. So from one year, it didn't change that much from the previous year. So you have to really pay attention to what's actually happening on, this is a percentage change in cost, not the actual cost. So beware of what you're looking at. Our last graph here is a pictograph. And graphs are established, they are embellished with additional artwork. So it can make it more appealing, but it can also distract you or mislead you. So in this one here, we've got the population going up here over the top. So it looks like, if you're looking at, oh, the people, it went up and now the population's maybe going down. So be careful of that. When you're looking at these numbers here, it looks like our population's going up at a steady rate, but you have to pay attention. The scale down here is not linear, which means it's not scaled in certain increments of time. So from 1804 to 1927, that's like 123-year difference, but from 27 to 60, that's like 33 years. From 60 to 74, that's only 14 years. And then we went up 13 years to the next one, and then 12 years, and then like 15. So if you're looking at the time frame, just be aware it's not like they're equal increments, but they kind of make it look that way. So they're spaced for visual effect, but the spacing does not convey accurate time information. So just be aware. Things are not always what they seem in the graphs. All right, so we have another question here. Does it make sense? So the rate of inflation in 1970s was much higher than it is today, so prices today must be lower overall. Well, that doesn't make sense either. The rate has been positive through the time period. Today's prices are actually much higher than the 1970s. The rate of inflation was high then, but that doesn't mean the prices overall were, because I remember prices, today's prices are much higher. And right now we are, at the time I'm making this, we have a high rate of inflation going on. And the prices are just going up on everything. So it'll be interesting to see when we get through this how the rate of inflation today compares to the rate of inflation back in the 70s. All right, so this got you through 3.3 and 3.4. And if you recall, at the beginning of this section, I was talking to you about some of the, like you need to be able to do the graphs. So we finished some of the graphs. There'll be more graphs coming. So just be aware of that. There's another activity, and this is figuring out if a line chart, a bar graph, a Pareto, a histogram, a dot plot, or a pie chart, which ones would be the type of graphs you would use. And you can just fill in with the A, B, C, D, E, and F for this. So you're going to answer the questions. And then on the back, you're going to describe the data as qualitative or quantitative. And then state the type of graph that you would think is most appropriate. There may be more than one appropriate choice, so choose the most appropriate one that you think and pay attention to some of the questions because it might help narrow down your choices, even though you might have, several that you could use. Which one would be the better one to do exactly what it says? So read the questions carefully. All right, and that'll finish up chapter 3. We will be moving on into chapter 4. So make sure you're getting your homework done and working on your StatCrunch projects.